Hi, everyone, and welcome to the second session of the Digitodontics Webinar Series. This is Mahmoud El-Bishti with you today from the Digitodontics International Academy. It's our pleasure and honor to welcome our guest speaker, Dr. Sébastien Baixe, from the Faculty of Dental Surgery, University of Strasbourg, France. Dr. Sébastien will share with us his experience in Introduction to CAD CAM Workflow in Removable Partial Denture. Dr. Sébastien graduated from the University of Reims, France, with DDS degree in 2004. He was a former intern within Prosthodontic department and in the Oral Surgery departments, University of Strasbourg, between 2004 and 2007. Also, a former resident at the Prosthodontic department, University of Strasbourg, between 2008 and 2012. He became a specialist in periodontology and implantology in 2012. Then he obtained his PhD degree in biomaterials from the INSERM Unit 1121 of Biomaterials and Bioengineering, the University of Strasbourg. He has published a first article on CAD CAM technology and removable partial denture in 2008. Dr. Sébastien is currently a visiting lecturer at the Dental Faculty of Strasbourg University, a part-time hospital practitioner at the University Hospital of Strasbourg, and he is owning a private practice in Strasbourg, France. So just before Dr. Sébastien starts, I would like to raise your attention that you can write your questions in the Q&A section. And once Dr. Sébastien finishes his presentation, he will answer your questions. So without any delay, once again, let us welcome Dr. Sébastien with us today. So Dr. Sébastien, I think the stage is yours, so you can share your screen, please.
Okay, so is it okay for you now?
Yes, it's we can see your slide.
Okay, so hello everybody. I'm glad to share this lecture today with you. It's an honor for me to be invited by Mahmoud. So I will present you an overview of CAD CAM technologies, but specifically not for the fixed dentistry, but the removable partial denture. So in this overview, you will be, I hope so, you will have a good point of view of what we can do, what technologies are able now at this point on what we can expect about CAD CAM technologies. So first, I will tell you that the prosthetic project is shared by dentists and prosthodontic, because when you are a dentist, you have to, in the normal project, you have to do the preliminary impression, and then when you have done your preliminary impression, the prosthodontic have to see what is your project. Is suggesting a counter proposal of your project, but you are the architect of the mouth, and you have to suggest them a design of the framework first, because you know you have more information than them. You have functional curve, okay, you have the vertical dimensions that you want to recreate, and moreover, you have the value of the remaining things. You know, if we can put a hook, for instance, in this toe that is mobile or not, but your prosthodontic lab is able to do for you a counter proposal, and then to do a dental individual tray. Then you can approve the draw of the project or the framework, and then you can do coronoplasty, melt crowns, and you do the functional impression, the secondary impression that you can send to your lab, and then he's doing, as you know, the dental working model, the metal frameworks, and you have to do the several assays sometimes, and you have your prosthesis. Concretely, I will present you a small photograph that you know, perhaps sometime know. When your dentist is receiving your framework, is drawing the framework on your master model, and in the red line you have the main line of insertions, and then with specific materials is waxing the undercut areas. Okay, so you can see on the photograph. Then when the wax is done, according to the main axis of insertions, he can scrape a little bit the zone of retention of the hooks, and it does a duplicate. Most of the time, the duplicate is done with the silicone mold. You have the male and the female molds, and when they are done, you can cast a refractory investment, and you have the duplicate. Okay, you can see at the bottom on the right. I don't have the small arrows, but you can see on the right of the photograph the duplicate. Okay. On the duplicate, when everything is drawn, you can wax the model with specific tools made of wax, bondable wax. And when everything is done, he adds screws until a cone, and he will put this master model completely in a refractory investment, and then we are starting the lost run method that you know very well. He puts the plots on the furnace, and you have a hole. Then you have small plots of metal, and he put them on the secondary pieces of the methods, and he put them in another furnace with centrifugation, and then you can obtain your framework. When the framework is obtained, you have naturally to clean it, to green everything, to see if there are metals that avoid to insert correctly the framework on the master model, and you have the finishing with the polishing surface that are very well done. And the end of the project is that you know very well, so I won't present you things that you know. At the end, you have a complete cases. So this is the classical technique. But in the digital workflow, how can we insert a removable partial denture? First, it started 10 years, perhaps 15 years ago, with you have the physical impression, the secondary impression to do, the functional impression, and then the laboratory had to cast the master model, to scan the master model. Then you had the first CAD, so completely assisted digital modeling. You had to do this with this master model with a specific software, and then the manufacturing was starting. You have many methods, so we will discuss about the main two methods. So what was this plan? So when he was receiving the master model, he has to pass it with the parallelizer in order to see the main line of insertion. And he had to put, when he had it, he put the master model on a smaller plate that you can see on the right side. And when it's done, he put the plaquette inside a scanner, a scanner of lab. And when the scan is done, on the main axis, the files are recovered on STL or PLY files. What is STL? It's a more common language from 3D CAD CAM technology. It's all of small triangles. It can have a very large definition or small definition. And with new technology, as you can see on these tees, you have very, very small triangles with a high precision. So new scans have more precision than 10 years ago. PLY is more specific for dentistry, but because you have colors, transparencies, but you don't need the PLY for removable partial denture, in fact. For the model, perhaps it's better for prosthetics, but you don't need so much. Then you have specific softwares. There it was Digitodontics as the second versions. And as you can see in gray, in the normal, in the classical way to do frameworks, the software is able to calculate the main axis of insertions. You can see on the red color that you have contour lines and that you want to have. So when the main axis is done, you have on the current software, you can choose on the toolbar for each piece of your framework. You can choose the limits first, then you have the limits. You can define it you can define it more clearly. You have smaller, you have the grid. You can define the size of the grid. You can define the number of holes. You can go very you can be very precise. Most of the time you don't need so many precision, but you can do more if you want. Technology is able to do this. Then you have you can add other pieces. You have the lingual bar design. You have the hooks. You have the tackets, brackets, everything you can add. And when everything is done, all the different elements are connected, and then you have to add a virtual sprue. Okay? When the sprue is added, you have your virtual framework in the software that you have to record in STL file. Okay? When it is recorded, you can't do the manufacturing. So we are discussing about the manufacturing later. What about the optical impression? First, the optical impression was invented by François Duret. He started this invention more than 13 years ago. So it's very old, but in reality, optical impression for removable partial dental are quite new, perhaps 5 years, perhaps a little bit more, but not so more, because it was not precise. It was not precise. The surface was very large in comparison with dental. When you are doing a single crown or a single inlay or lay, it's a small size. And if you want to avoid errors in a wide area, like for removable partial denture, you need sufficient precision. And now new technology, new camera are able to do this. And they are selling to you, dentists, for doing digital modeling directly. But as I was telling to you first at the beginning of the presentation, we think in this faculty that the optical impression need to serve as from the first impression, the initial impression. So you have several cameras. It's the same camera than for the single cross. You have prime, scan, trios, medit, hive, medit, new medits, the condor, etc. So the preliminary impression, you do your preliminary impression. At the beginning, we found that you can track lines in order to help you to follow the camera when you are recording the palette. But with new tele technologies, I think we don't need so much. When you have recording your palette, you have to record also the occlusion, the lower jaw, and then you have the model, the virtual model. And in this model, you have a crown to do, and you can also discuss with the lab of the projects of the hooks that you want to put. As I was telling to you, you will send it to the lab. He has a counter proposal, and you can decide if you want to accept or not. And then you can do the functional impression. So don't think to coronoplasty before, because when you have new technology, sometimes you think everything is done and you have to be rigorous. You have to work as before coronoplasty. For the functional impression, you can be helped with dental ecartos. You have Optragate, for instance, on some ecartos that can help you for photography. And then you can have plot or draw line if you want. And then you have to start the impression. The better thing to do is to start with teeth and to start for the lingual or the palate surfaces. Then you go to the occlusal, and you are going to the crest, and you are going back then to the vestibular faces. If you have lax or other zone, other area that are lacking to your dental impression, you can pass the camera as until you have a correct model. Okay, you have time. You can repass several times in the same teeth, and then you have a correct model. So this model is presenting as on these pictures. So we did the lower jaw, the upper jaw, and we have to record the occlusion. So it's easy with the camera software. And then you have to record this in STL or PLY, like I was telling to you. And that's done for the optical impression. And now what about the manufacturing? The manufacturing, you have two kinds of manufacturing that we can do. Actually, you have a mixed that combine CAM technology, computer-aided design manufacturing, with a traditional method, and more industrial method that we will see in this presentation. So for the first mixed technique, what is suggested? It is suggested that you have to create a rapid prototyping of your framework with a burnout resin. Okay, this burnout resin will follow a loss-fast process, and you have three kinds of process that are existing. You have milling, 3D impression, or stereolithography. For milling, it's easy, as you know. It's like from dental crown, dental single crowns, bridge, on inlay, onlays. You have to buy disc. Your lab have to buy discs in a burnout resin, and during the night, the machine is milling your framework, and then the following day you are recovering your framework, and that's okay. For the 3D impression, it's a very big 3D printer. Then you have to import the STL file in your printer, and the printer has two aids of impression. The first aid is for paraffin, and the second is for burnout resin in a liquid mode. And during the night, it takes about 8 hours. It is printing. There's two layers until doing your burnout resin on the paraffin on the holder. And then the paraffin is removed in hot water, and it can be put in the master model. And you can see in this rapid prototyping if everything is okay, everything is correct, the hook, the form, the design, etc., etc. At last, what about the stereolithography? The technology is not so hard to understand. You have a lamp, you have several lamps and mirrors, and you have a bath of photopolymerizable resin, and then you have a plate. And the lamp is sending to the plate light, and the light will photopolymerize the resin at the surface. The plate, the upper plate will go upper, and then you will have your framework. Your framework is like this, and you have to clean it, and you have many supports, many lines that you have to remove after. But it's a sort of 3D printers that you can see in the commercial for laser, for many things. So all these three technology follow a lost wasp process. Okay, it's the same that I was explaining to you at the beginning of this presentation. So you can add many frameworks on the same block. You have to put an investment, and then at the end of the lost wasp process, you have to break the plot and to recover the framework. You polish it, you make it very clear. Your lab is doing this. You can try it, but most of the time you are not trying a nude framework. Sometimes you are taking you are recording the occlusion, and then as you can see on the photograph, it's very correct. The precision of this technique is very high, and is very like, as you know, for classical technique. And then we will discuss, we will have just an overview of the direct 3D printing. What is this? It's you have two technologies that are very close. You have selective laser melting or selective laser sintering. For melting, it is just an aggregation of plots of metal, and then it is sintered in a furnace. With the SRS, it's already sintered, but technology are very close. So what is the technology? It's very big machines that need to record first your STL project. You have a metallic powder reservoir on the up to the plate 1, and at the plate 2 you have the working plate. So you have a roll that is bringing to the second plate a thin layer of 10 micron of metal or powder of metal. you have a CO2 laser that is sintering your first layer. The second plate is going down. The first plate is going up. A second layer is coming. You have second layer of CO2 laser that is sintering to the first layer, etc., etc. Okay. At the end, you have to aspire all the powder that is remaining, and then you obtain the framework. You have to clean them. You have small sticks that you have to remove, that your lab has to remove after. In this technology, the furnace for selective laser melting is not the same as selective laser sintering, but everything has to pass in a typical oven. And then you have your framework that you have to put on the master model. If you have a master model, then you have to do the finishing, as you know, like a classical method. And then you can see the accurate finishing, as you know, for the classical removable partial denture. So this is the classical technology. I will just add the peak on like polyether keton that you will see perhaps in internet, because we are speaking, we are discussing. There is a lot of things that can be presented to you with a CAD CAM technology. What is peak? Peak, it's not a new material. It's an old material that have 40 years old. It's considered as a very strong polymer, and it is a strong polymer. It is used for planes, for very high technologies. And with this kind of technology, we can mill in disc, we can mill frameworks. But I have two suggestions of question for you. What about the strengthness of the lingual bar, for instance, because it's very fine, it's a plastic. And secondly, we are discussing about aesthetic. I don't think, if you consider aesthetic, there's a too high blank oak in comparison with metal oak. So I don't think the aesthetic actually is not a good reason to use the peak. And secondly, peak, if we see the reality, the property of the materials, first, to compare the Vitalium. As you know, Vitalium is a classical method to do frameworks with classical method. You have cobalt, you have chrome, you have molybdenum. And with the SLS and SLM technologies, you don't have you have a little bit molybdenum, but you have mainly tungsten, and the framework is more strength. It's not the same elasticity. So when I'm working, when I am activating hook, I do prefer to do it Vitalium because it's more easy. You have to be careful with Romanium method because it's a little bit different. And when we want to go further, sorry, it's in French, but you have the property of materials, Vitalium, Romanium star, and PEEK. When you compare Vitalium to Romanium star, the property are a little bit closed, but with PEEK, as you see, it's 10 times less resistant to traction. The alignment of elasticity is not the same as metals. And I think that if technology is able to do a framework, I don't think it should be it should be considered as a standard, the PEEK. So the Vitalium and so the Romanium star should be considered as a standard method, but not the PEEK. The PEEK should be reserved for other things like bar, for implants or for things like this, but full arch denture for implants, but not for removable partial framework. So I will show you just one small clinical case. What about this case? So it's the lower jaw. So we are recording the lower jaw, the upper jaw, the occlusion. Then at the left of at the right of the slide, you have the framework that is done with classical software. So it is sent to be done with SLM methods. Like you can see, you can see the small sticks next to the hook. In this kind of method, we was assigning the framework, and the framework has a specific saddle. Why this kind of saddle? Because the optical impression is not a functional impression. Okay, so in this case, we wanted to record the functional, the tissues in functional activity. So we decided to with this saddle to use classical materials for impression, impressive impression for impression for tissues. We record the occlusion, and then we don't have any model because everything is done with CAD CAM technology. So in this case, we record with the first impression. We decided to print a model in resin, and in this model we had to remove 2 millimeters of resin because between the framework with the impression and the model you have a hole, and the hole should be completed by the functional by the tissue in function. And what we've done is to put a specific silicone between the saddle, the impression under the saddle, and the main model. And there is a silicone, and the finishing was done up to the silicone. And the finishing was a classical method. As you see on the photograph, the precision is very, very high, and it's correct, and everything is good. So it was, if you want, I can send you, if you want, an article. It was written, it's in French, but if you can't understand French, photographs are easy to understand, and we explain this method. So to conclude this small presentation, CAD CAM technology for removable partial dentures are a real progress for the lab. It was first done for the lab because it less arduousness. You don't have toxic things to rear. It's easy. You have mainly you have to masterize a new technology. It's not the same job. You don't have cast error, but your machines need to be controlled each year, each 6 months. It depends on the machines, and it's good also because if your lab don't have all the machines, you have connections between other labs. You can delegate one piece of the work to another lab, and then to take it back and to finish what he's about to do with this kind of technologies. And for the dentist, it's also a progress because you don't need to do several impressions that are difficult sometimes because of the nauseous reflex, because it is lacking materials. You have small imprecision, And if you are not precise on the tools, you can insist with your camera, and then it will be better. You have less steps, and then less steps are less imprecision. So for everything. And you have small things that we could discuss, but it's more precise. For instance, when you are doing a crown under removable partial denture, you can let the prosthesis to the patient, because normally you have to take the prosthesis, and the lab has to adjust the new crown to the removable partial denture. But when you can record everything with these new technologies, you can let everything to the patient. It's good, he has time, he's with the temporary crown, and it's good for everybody. And it's a progress, but sometimes you have the necessity to do a functional impression, as I was telling to you. So it's not all the same, but it's possible, and you have technology, and it's not so huge to do. It's quite easy. So that is my conclusion in this small presentation. Thank you, Mahmoud, and let you for the.
Yeah, thank you so much, Sébastien. It was very nice that you explained to us the entire digital workflow for removable partial denture. It's nice that you started with the conventional way of producing this kind of removable partial dentures, and then you mentioned about the mixed techniques that use the conventional ones and some digital workflows, and then you mentioned and explained to us the almost total digital workflow for the removable partial dentures. So I thank you so much for this presentation. Well, once again, I would like ask the participants if they have any questions. So please write it down. Sébastien, it's clear that the digital workflow, it's more cleaner and cut off a lot of procedures for both lab and for the clinic as well. But as you have mentioned, the material sometimes is challengeable. For example, for the beak, they have the issue of the static. For example, for the clasps, it's very thick, so it's not really good. Again, the metal framework is still more suitable for static, for strength, and for everything. So what do you think about the future of materials for the digital techniques for removable partial denture?
The future is complicated because, as you know, sometimes you have to combine the strength of the materials, the easiness to do things, and actually you don't have other materials than metals that are able to support a great case. Perhaps a pig can be convenient for small cases, but the metal as you know, sometimes you have to activate hooks because the process is a little bit old, and it moves, and when you activate hooks, your prosthesis is okay, but you don't have plastics that can be activated. It's simple, but it's normal. It's that we are doing now. So I don't believe in plastics sorry. It's
You are the expertise, so
yes, it's but perhaps you have a better materials in the future. But it's just funny because for Europe they are discussing to about the metals. They are telling that metal is not the perhaps should be avoided should be removed for removable partial denture, but they don't have any other solutions. And perhaps you will have more neutral materials, but if you want aesthetic, you have other solutions. For instance, you have, if you want to avoid hooks, okay, it's implants. You can add an implant plus a locator if you have this kind of solution that is not so bad. And you have other solution. But in my opinion, actually, I don't see other things that metal.
yeah,
Sorry.
So you mentioned also another challenge when you apply the digital workflow, CAD CAM workflow, which is the impression. We know that functional impression is very important in complete and removable partial dentures, but by using optical impressions, so it's still a mucostatic technique, and sometimes it's very challengeable to reach the functional unless you need to do it manually. I mean, you know, as you explained. Do you think that will add extra steps for the practitioner and also for the patients?
Extra steps to do a functional impression?
Yes. I mean, when we're trying to use the digital workflow, you're trying to shorten the time and the steps and everything. But again, you still need to have the functional impression to improve the function of the denture. So do you think that a barrier for the digital workflow?
No, because perhaps in the future camera will be able to record the mucoses, but progress are very, very high. But actually, for instance, for class 3 of Kennedy, for small cases, you don't, and it depends on the case. For some cases, you don't need to do an extra functional impression. But I presented to you a small few cases where we need a functional impression, because I can imagine that it's just a mucosis like this, and if I record just with optical impression the mucosis, the mucosis will be compressed by the prosthesis every time. And with the small technique of silicons, it's not so difficult, but you have to print again a new model. So it's a lab problem, but it's not so difficult. You can see for a few minutes a patient to do this small impression, and then that's okay. Okay, you can if you want, you can do an alginate impression to recover everything, but it's a pity to use again classical materials to combine CAD CAM technology. But sometimes it depends of the lab with who you are working, and if they're able to follow you with the digital impression, it's not only a dentist problem. It's a team problem. You have to combine what your lab is able to do and what you are able to do. But it's clear that actually with actual camera, you are not able to do impression in function. It's clear.
Yeah, that's true. That's true. So I think we came to conclude our webinar session. I think the attendee is a little bit shy to ask. I don't know why, but I think we are going to conclude our webinar today. So it's a Digitodontics tradition that present a certificate. So we would like to present you a certificate of appreciation. We hereby express our sincere appreciation to Dr. Sébastien Baixe in recognition of his contribution as a live webinar speaker for Digitodontics webinar series on the topic of Introduction to CAD CAM workflow in removable partial dentures that was presented on Tuesday, November 8th, 2022. So, Sébastien, I'm so glad to having you here today to share with us your experience, your expertise in this field, and you enriched our knowledge with all this information. So thank you so much, Sébastien.
Thank you for your invitation, and I was glad to share all this technology with you, and see you soon, perhaps. Thank you.
Thank you. Thank you. Have a nice day. Thank you.
Have a nice day also. Thank you.
Yeah. Thank
Bye.
you. Bye-bye.